Now let's consider a solution of a weak base. So let's consider methylamine. It's a weak base. It has a Kb of 4.4 times 10 to the minus 4. And so we start with a 0.02 molar solution of this weak base, and we want to know what the pH of the solution is. Well, we have methylamine. It's a weak base, so I'll just represent methylamine as B for base. A base reacts with water. A base is a proton acceptor. Water donates a proton to the base, so we end up with Hb plus and OH minus, what's left of the water after it donates a proton. So this is the reaction of a weak base in water. So we have our equilibrium expression. We call K sub B for base. It's the concentration of the products divided by the concentration of the reactant. Water is a pure liquid. We don't include it in the equilibrium constant. So now we can let X equal an extent of reaction, and for weak bases it's convenient to let X be the OH minus concentration. And that means since the 1-to-1 ratio here, X will also be Hb plus, and the concentration of the base at equilibrium will be the initial amount minus X, because 1-to-1 ratio. So now we can put the X's into the equilibrium expression. We'll get X times X over I minus X. So this is the same form we had for the weak acid, only now X is equal to the OH minus concentration. So when we solve for X, we're getting OH minus concentration. We'll have to use the autoionization of water to get to the H3O plus concentration to find the pH. Just one extra step. So let's solve for X. So we're going to have X squared plus KBX minus initial concentration times Kb equals 0. So we can plug numbers in here. So Kb is 4.4 times 10 to the minus 4. Initial concentration is 0.02 molar. So we can use the quadratic formula. X is equal to minus B, which is K sub B, plus or minus the square root of B squared. So that's K sub B minus 4AC all over 2A. A is 1. So we can plug numbers in here now. The initial concentration is 0.02. Kb, put in these three places, is 4.4 times 10 to the minus 4. So plugging in numbers and solving for X. Now remember, since we're starting with a negative Kb, we're only going to use the plus root here because X has to be positive, because it represents the concentration of OH minus. So I get a value for X of 2.8 times 10 to the minus 3, and this is the OH minus concentration. So to find the pH, I need the H3O plus concentration, so I use the autoionization of water. Equilibrium, and Kw is the constant, 10 to the minus 14th. So the H3O plus concentration is equal to 10 to the minus 14th, which is Kw divided by OH concentration. That gives 3.6 times 10 to the minus 12th. So taking the negative log of that will give me the pH A pH of 11.5 or 12. So we have a weak base in solution. You can see the pH is above 7. It's a basic solution. So we handle the equilibrium the exact same way as we do with a weak acid. The only additional step is determining the H3O plus concentration from the OH minus concentration, which we solved for a base equilibrium.